Good morning. Today we are going to talk about what's called the squeeze theorem, or sometimes called the sandwich theorem. And it's a pretty easy one to understand. It says, assume that functions h, f, and g satisfy the following. And I'll draw you a little mini sketch of what this is all about. All right, so first off, you have h of x being less than f of x, which is less than or equal to g of x. So essentially you have an h, well, that wasn't the right thing, an h of x equation, all right, that's happening down here somewhere. And then up a little bit above it is the f of x equation. It could be doing something else. And then up here is the g of x equation, and it's doing something else. And that's, of course, all set on a coordinate grid. So it's just talking about the location of the graphs. And you can see one down below. It's a little more realistic, where there is a line here. There is another one here. And then there's this other one that's sandwiched in between them. And as the green and blue one get closer and closer and closer, so does the red one. And then eventually, again, they start to spread out again. So that's the idea. And what the theorem says is that if the limit as x approaches a, and let's just look at this graph that's down here at the bottom, and it's hard to see, I just wrote all over it, but they've got a being right in here near the origin. So as x, or the limit of h of x approaches a, that would be, for example, the blue one. That'd be the h of x. That'd be this one up here in blue. All right. It's supposed to be, whoops, I did it backwards. The h of x would be this green one, because h of x is supposed to be the smallest. All right. If you know that the limit as x approaches a equals this random number L, which just stands for limit, all right, it equals that number. And you also know that this other one, the g of x, the bigger one, this one right here, as it approaches a, same location, it's also equals the same limit. So essentially the blue and the green one are touching right there in the center at a. Well, then that means that the limit of the red one, which we don't really have any information on, is equal to that same number because it gets squeezed in between the blue and the green one at that particular point. But since the blue and the green one are equal, the red one can't kind of escape from it. So it is squeezed in between and thus has the same limit at that particular spot. All right, so again, this is called the squeeze theorem. You've got two graphs that are squeezing in another one in between them. And again, at a certain spot, if those two graphs are equal, then the third one that's squeezed in between them is also equal. All right, let's try an example. All right, so again, it's all assuming this kind of order to the pattern here. H is the smallest and G is the biggest and F is in the middle. We're looking for the one in the middle. So if I know that the one on the left, the smaller one, h of x equals equals 1 minus x squared. That's not a negative, that's just an ugly equal sign right here. And that g of x, the biggest one on the right over there, is 1 plus x squared. And we know that f of x is jammed in the middle. And we want to find the limit of f of x as x approaches 0. So what we're going to do is we're going to first find the limit as x approaches 0 for the h of x function. And we find out that that means 1 minus 0 squared, which equals 1. And then we're going to do the same thing for the g of x. We're going to find the limit of the g of x function as x approaches 0. And that would be 1 plus 0 squared, which also equals 1. So again, if I've got an inequality, and on the left I got 1, and then in the middle there's this f of x, and on the right I got 1, and f of x has to be in the middle, it has to be squeezed in between. Well, what's f of x have to be? Well, because of the or equal to signs in there, we know that f of x has to also be 1. Because it's been squeezed in between the other ones and there's no room for it to go without breaking out from them. So it also has the same limit at that point. All right, hope this helps. Good luck today.